So let's do a little more trig review, right? I've got a 52 centimeter vector here. This could represent any vector. So it could be a momentum, it could be a force, it could be a velocity, it could be an acceleration, a displacement, right? Whatever. And we happen to have the angle on this one. So we could do something like resolving it. Let's say you want to know how far you went in just the x direction, right? So you could drop a vertical and measure right here, or I could use my trig functions. So good idea on these videos to pause and work ahead of me there. But if I wanted to know my x displacement, if I wanted to know this red x displacement, then I could use one of my trig functions. So if I start thinking, well, I know the adjacent angle, right? And I know my hypotenuse and I know my angle, right? So I could say my cosine of theta equals adjacent over hypotenuse. So I go plug it in. Cosine of 32 degrees equals my x value over 52 centimeters times 52 centimeters by both sides. Cancels out over here. So 52 times cosine of 32. So 52 cosine of 32, right, is all I have to do right there. So I did 52 times cosine of 32, and that gives me an x displacement of 44 centimeters. Or if this was newtons, this would be 44 newtons, that kind of thing, right? We could also do a vertical on here, right? So we could say, well, I need an eraser. We could say, well, which trig function do I want to use here? I could use any of them. Well, not any of them. I couldn't use cosine, but I could use tangent because I do have adjacent and I have opposite, but I wouldn't love that because I calculated that. So I prefer the opposite over hypotenuse, which is the SO of SOHCAHTOA. So sine of theta equals opposite over hypotenuse. So sine of 32 degrees equals my y value over 52 centimeters. Kind of start to see some pattern here, right? So we multiply both sides by 52. 52 sine of 32 gives me my y. So 52 sine of 32. And my y value is 27.6 centimeters. Really 28 centimeters because we've only got two sig figs there, right? So really that we just resolved a vector there, right? But sometimes we get different information and different people are comfortable with different things. Let's say some of us didn't seem real comfortable calculating an angle on there. So let's say we've got some other one. Ooh, we're gonna go in inches because I happen to do inches. So this is 19 inches. And then my horizontal appears to be 16 inches. So let's calculate the other things with this, right? Again, I could do it graphically. I could throw my protractor up there and I could measure that. And if I've been reasonably accurate, my measurement there would be reasonably accurate. But we could solve for this one with the Pythagorean theorem. And we seemed fairly comfortable with that the other day when we were doing it, but we do want to be careful there because I'm not solving for the C part on this one, right? So it would be like, instead of a squared plus b squared equals c squared, I'm going to use x squared plus y squared equals resultant squared. Same idea, a squared plus b squared equals c squared, x squared plus y squared equals resultant squared. So my x squared is 16 inches, and I'm going to square that, plus my y squared equals 19 inches, the whole thing squared. Right, so now that's enough work for me, but some of us don't love rearranging things as much. These are attached by addition, so we'll separate them by subtraction. So I'm going to subtract that over. So I would do 19 inches, the whole thing squared, minus 16 inches, the whole thing squared, equals y squared. So I need to square root both sides then, right? So I'm going to go ahead and go to my calculator at this point. 19 squared minus 16 squared equals that, 105. So then I do square root of 105. Square root of 105 is 10.2 then, right? So this value is 10.2 inches. Let's see if we're reasonably close graphically, right? Since I just kind of estimated vertical and that kind of stuff. about 10.5. That's not too bad for just estimating vertically and all that kind of stuff. And now again, I want this angle. Now the other day in class, all the examples we had when we were adding vectors were all tangent ones. But in this one, I wouldn't like tangent as much because again, I calculated that 10.2. So I have hypotenuse and adjacent. So that is adjacent over hypotenuse is cosine. So this is going to be a cosine. Let's use green for that. So theta. So cosine of theta equals adjacent over hypotenuse, or x over resultant. And so since I have those two and I'm looking for the cosine, I'll use the inverse cosine. So cosine of theta equals 16 over 19. Inches in both spots get canceled out. So I'm going to do inverse cosine, right? So second cosine, and different calculators have it in different spots, but it's the cosine to -1 divided by, and then 16 divided by 19, 32.6 degrees. Wow, did I get another one that's about 32 degrees? Where I just kind of started drawing stuff. And this looks like it's, yeah, right at 32 degrees. You probably can't read that at all, but yeah, it works out to be 32 degrees there. Right, so just keep working on those trig functions and stuff, and they'll get easier for you.